Everyone, thanks for taking the time out of your day to join us for this webinar. Today we're going to be learning about the benefits of using thermal imaging drones to do solar panel inspections. My name is Randall Warnes. I run the FLIR Small Unmanned Aerial Systems business. I'll be co-hosting this webinar with our friends from Raptor Maps. Now, Raptor Maps was founded by MIT engineers in 2015 and has investment from the Y Combinator and the Commercial Drone Fund. The company builds software to pull insights out of drone data, specializing in artificial intelligence and thermal analytics. The company's industry-specific solutions include Raptor Solar for PV inspections and Enterprise AI for industrial inspections. Now, we're privileged to have Nikhil Vadhavkar, the CEO and co-founder of Raptor Maps, with us. He's previously developed thermal control systems for advanced spacesuits at MIT and led a Bill and Melinda Gates Foundation grant for deploying drones to deliver medical supplies in developing nations. Nikhil, what is going on?
All right, thanks, Randall. So yeah, I'm excited to join everyone here today, and you know, we have a lot of interest in this, and there's a reason, you know, SUAS.
Sit tight one sec, Nikhil. Hold on one sec. We gotta go through the agenda first.
Oh man, we gotta tell people what to expect. All right.
All good, man. All good. Today we'll be covering the basic considerations of operating drones commercially. We'll also discuss the value of using thermal imaging drones for solar inspections. Then we'll really get into the meat of best practices when inspecting solar farms, large and small. This will include planning the inspection, collecting the best imagery, and creating deliverables that will drive the most value for site management and corporate teams. Now, after that, we set aside roughly 30 minutes to hold a question and answer session. So please feel free, and I encourage you to submit questions throughout the session in the questions panel on the webinar dashboard. Now, this session is going to be recorded and available for review. We'll send it out within the next week. Lastly, stick around as we'll be making an exciting announcement from FLIR at the end of the presentation. Now, Nikhil, my man, hand it over to you.
All right, let's take it away. So yeah, so why is SUAS for solar taking off? There's a huge boom right now, and I think it's really good to step back and understand that and get a little bit of an overview on the drone industry for those of you who may be coming in from the solar side of it today. So. You know, there are a few different reasons. One is there are three main factors. One is that it's a lot easier to obtain an SUAS operator certificate. So it used to be in the past that you needed to have an actual pilot license from the FAA, Section 333, and all of that. And now it's become much more like a boating license almost, where as long as you can be incredibly safe and you can take a test, you can obtain that certification. The second big reason is that the hardware has become much more tightly integrated and purpose-built, and you're kind of seeing that. So, you know, back in the day, it used to be a lot more Arduino type stuff, and now it's a lot more, you know, Apple computer look and feel, like everything just kind of works. And so now we're seeing a lot of this plug and play, you know, drones, thermal cameras, it's all working together really nicely. And then lastly, what's making, you know, solar really special is that there's just a huge amount of demand. So in the industry itself, you're seeing double-digit growth year after year. That means more installations to inspect, and the old ones aren't going anywhere. So now companies are having a shortage of really good technicians, and there's incredible pressure to make them a lot more productive and make sure these assets are performing. And so drones are picking up both major issues and minor issues, and we'll see some examples of that today. And they're really answering the question of, you know, where do I have issues and why, getting down to that root cause. All right, so let's show some examples of, you know, let's make it a bit more tangible, understand why aerial thermography is so useful in this space. So here's some example images courtesy of Solve. They're a major solar O&M provider with a drone program. Let's go through some basic terminology today for those of you who may be coming from the drone space, so we all are kind of on the same page. So the module is what we typically think of as a solar panel, and a bunch of panels wired together in series is a string. And many strings come together at a combiner level, so you'll see an example of that in the top middle of your screen. And the largest unit in a solar farm or a PV system is generally the inverter, and that's where that it goes from DC to AC power. And so there are a lot of different technologies to build a solar farm, so that hierarchy is not always the case, but it's pretty good to think of it in those terms. So if you start in the upper left, you can see an example of an inverter that's keeping an entire section of that solar farm offline. The combiner we talked about, the tilt tracker in the upper right. So these are motors that actually move the panels to track the sunlight. You can see those pretty well. String level, so that's a lot of modules that's wired up in series. Now shading is kind of an interesting one because you would think that, oh, it's not a big deal. You know, why is my I've only got a little bit of shade in the corner, but it's really, you have to think of it like a pipe where, you know, even a little bit of shading, because of the way that, you know, these modules are wired, and within that you have these cells that are wired, it's causing a clog in that pipe and can actually knock an entire module or an entire string offline. And finally, you can see module level defects, which you're looking at in the bottom right corner. All right, so let's talk about, you know, the.
Hopefully you didn't just drop off, but yeah, I wanted to talk a little bit about what thermal imaging is and how it plays an important role in solar panel inspections and other commercial applications of drones. So as many of you would know, FLIR is the largest manufacturer of thermal imaging technology in the world, and fundamentally, thermal imaging cameras allow you to assess the relative or actual temperature differences within a given scene. Now, every physical object creates, reflects, or absorbs energy, which comes off as radiated energy. Thermal imaging cameras see into the particular band of energy that can't be seen with the human eye. Then this is translated into a temperature so that it can be commonly understood and communicated. Then finally, those temperature differences are laid out over a color palette, providing a visual representation or a range of temperatures within an image. When used with drones, thermal imaging cameras provide commercial and civil users a top-down perspective, which could only otherwise be provided by manned aircraft at a much higher cost. So thermal imaging cameras are currently the most promising payload for drones in the industrial space, and their deployment can result in greater efficiencies and safer operations. Solar farms are generally located in remote areas and can cover anywhere from 1 to 100 acres. A single farm can contain millions of photovoltaic modules, outputting clean energy vital to support the rapidly expanding global population. And this makes the inspection and maintenance a necessary component to maximizing outputs from these farms. Traditional inspection methods are either done by foot, trucks, or other ground-based vehicles, which can be time-consuming and are relatively inaccurate. Inspecting solar farms with drones is claimed to be 6 to 10 times faster than traditional methods and can potentially save hundreds of thousands of dollars by addressing the problem areas that are identified. Solar panel inspection is also one of the most visually compelling cases for thermal imaging drones, as thermal sensors are already a key component in traditional inspections, which are otherwise very cumbersome and time-consuming without them. One of the significant advantages of drones inspections is that these can be repeated precisely to assess changes over time and done autonomously, keeping the efforts of piloting the drone by hand minimal. As future regulations will allow, it's possible that drones could be housed at the site itself and deployed at set iterations without human involvement. This could lead to the development of an anomaly detection software that could alert site management of problematic areas and send technicians straight to the location. When using thermal imaging drones, you can expect to see defects manifest themselves at the string, panel, and even the cell level, and these defects can be seen as hotspots where electronics might be overheating, or as cold areas where solar energy is not being absorbed at all. But this is not exclusive to only the issues with the panels, but also junction boxes and other electronics behind the panels that manage the energy and that can pose problems for the site. With aerial thermal imaging, these issues can be identified through the same inspection process. So with the ultimate goal of increasing the output of the farm, thermal imaging drones have a distinct advantage over traditional methods. So I'm going to pass it back over to Nikhil, and he'll go into how you do these inspections. Nikhil?
Yep, can you guys hear me okay?
Can hear you just fine.
Fantastic. So let's talk about how to plan your inspection for different types of, it really depends on what you're looking to do. So let's dive into that a little bit. So, why did I bring my drone out to, on this bright and sunny day to take a bunch of thermal images of a solar farm? The drone it's a fantastic means to an end, but the analysis is where you're getting the real value out of it. And it's really going to help you to match your client's expectations with yours. So something to note about the solar space is that it's traditionally the asset owner that has either a separate division to do operations and maintenance, or sometimes they'll pay a service provider to do operations and maintenance to maintain the solar farm and keep it in top shape. So it's important to understand, for those of you coming from the drone side, who your customer is. So for commissioning, that's really when you're turning the lights on for the first time for a system. So you might be looking for major issues to give the team a heads up and save them some time. Or maybe you're looking at a site after a weather event like a hurricane or hail damage, and maybe your client wants to know, okay, which modules do I need to swap out? You know, do I have any major racking issues? Do I have wind damage? Things like that. Or maybe you're assisting in a warranty claim where, in which case you're helping provide the proof that, you know, this module is actually defective in order to help the asset owner swap that one out for free. You may also be facilitating an asset transfer. You know, just as if you were selling a home, you want to bring someone in to do a thorough, good inspection. And so you might be doing something like that. So a good thing to think about in general is, you know, what level of detail is your client looking for? We talked about the parts of the solar farm earlier, but there are even smaller parts. So some modules are grouped into diodes, and that can even be further broken down into these 6-inch kind of cells. But the flight and the turnaround time can be a lot lower if your client's just looking for larger issues and maybe they don't really care about those occasional hotspots. So you really, really want to make sure you're matching your inspection to what the client actually wants and needs. So that being said, there are some general guidelines that will always serve you well when you start to plan your inspection. And location is the biggest one. So it determines, you know, do you need to request airspace? What is the expected weather? Because you want to maximize that sunlight. One thing people don't often think about is, you know, is there a satellite image of the site? A lot of these sites are newer and it may just be a forest or a field. And if the answer is no, then if you're flying your drone, you may want to think about making a quick orthomosaic. Another consideration is the module technology and the wiring. And at Raptor Maps, we use this in a couple different ways. It really helps to, you know, inform a site-specific plan. Just knowing the module gives us the dimensions. If we know how it's wired, then it's much easier to program in. Oh, you're looking for, you know, 12 modules to a string, and when you see 12 consecutive modules that are out, that manifests as a string issue. You can also, you also want a high altitude site overview. That one's really simple, but often it's missed. So, you know, remember you're mostly imaging for relative temperature differences. So, you know, if you're zoomed in at quite a bit and every single module is affected, you know, in the case of that inverter we saw earlier, for example, you might be missing the forest through the trees if you don't have a nice wide site overview. And thermal, you know, where obviously the focus today is on thermal, but you know, it's a very important part of the story. But you know, just that normal color imagery really helps with determining causation. So instead of just saying, oh, there's some hot spots here, now you can say, well, something's shattered, or perhaps this is soiling, like bird poop, which is actually a pretty big deal because what we talked about earlier. So this can really help inform the what's going on the solar farm. So finally, good records and data quality. I mean, this should always be part of your standard drone flying process. We always see that people may take great flight logs, but they may not always take the best data logs. So we'll often see sections that are reflown or imaged at a couple different altitudes, and it's really helpful for your own records when you go back and you've got all this data to understand, oh, you know, the second flight, the images turned out better, this was the eastern section of the field, things like that. And then verifying the data quality on site. We've definitely had customers that will fly only to realize, for example, their camera wasn't taking radiometric data, or they were going too fast in skipping sections and there was motion blur. And so there always is that little bit of, you know, time pressure at the field, but it's always better to take the extra second and make sure your data is good before you spend all that time out there, because you want to come home with the best data possible. So how do you get high quality data? And more importantly, how can you do it in the least amount of time? One of the things you'll see in the solar industry is it's all about optimization. And so oftentimes we work with customers that want to be able to image many different sites in a day. And so they have to optimize their workflow in order to do that. And so, you know, at Raptor Maps, we've reviewed data from all kinds of different drones, cameras, solar farms, you name it. We've discovered that basically whether it's software or it's humans, tracking along a row works really well. So, what you don't want to do is fly 45 degrees to how the farm is laid out. So you either want to pick one, go parallel or perpendicular, and pick one and stick with that. A common question we get is, how do I fly to make a map? And so I just want to clarify right now, the larger the installation, the less likely a map is to come out. And so, at the altitudes when you can see meaningful features, that radiometric map, especially for utility scale or bigger installations, is probably not going to come out. So when you're out there and you want to be able to guarantee a deliverable, we don't necessarily, we don't recommend making a radiometric map. And so why I'm telling you this and what it means for your flight plan is, it means a couple things. One is you can reduce that side lap. If you know that you're not making a map from this, you're just making a really high quality solar deliverable, you can reduce it. If you go from 90% to 80%, for example, that saves you half the time. And you also want to keep, in terms of front lap, you do want to keep that pretty high. It shouldn't really slow you down at all because it's in the direction of flight. And it really helps with tracking defects from image to image. So you can kind of see that graphic on the right side illustrates that. Now, if you're in a multi-copter, highly recommended that you maintain your camera heading. And this is for two reasons. One is you won't lose your frame of reference. So if you've ever tried to track the imagery and then the aircraft rotates around completely, it is a little bit more difficult to have an understanding of which module or which row did I cover, and which how does that relate to the next pass. But the second one is, if you adjusted your gimbal for a couple of reasons, right, to avoid glare, to get a better view of the modules, now you're looking at the backside of the modules, and you're not going to have the optimal gimbal angle. So for those two reasons, definitely try to maintain your camera heading. It's okay to tilt your gimbal to avoid glare and get a better view of the modules. It's not okay to tilt it at extreme angles, and for thermography considerations, you don't want to be dead on to the modules. All right, so other best practices. You want, you want really good weather. You want a good sunny day, and the reason for that is that the higher this insolation, watts per meter squared, the more likely you are going to see, the heating of the defective modules relative to the other modules. If it's a really cloudy day, or you don't have a lot of sunlight, you're not going to see that. You want to avoid glare, which we talked about. Definitely avoid motion blur. So be very cognizant of the fact that if you're flying really fast, you don't want to be flying really fast and really low. High altitude site overview, which we talked about a little bit earlier. RGB ortho, if you have no satellite imagery, very good practices, and checking your data and your metadata. Now, on the right, I just want to show you an example. We get asked this question quite a bit. Why should I collect radiometric data? And you can see an example of that here. So in this image, there was a glare spot, and that causes the rest of the image to appear dark. Now, if you are not taking radiometric data, you're stuck. This is the picture, right? It is what it is. Whereas if you have radiometric data, now you have the ability to move the temperature sliders and expose the image properly. And also, almost everything we're talking about today is based on qualitative image analysis. But if you ever do want to go back and do more quantitative image analysis, then having that radiometric data is a must. All right, so let's talk about the most valuable deliverables for solar clients. So you've collected your really high quality data. We've really beaten that into you. You're making sure everything's good. All your metadata is in there. It's these images are ready to be analyzed and delivered. So the first thing you want to consider is who is actually receiving your deliverables, because there are a few different players, and they all have a few different things that they want to see. And so if it's management, right, they're making decisions on which issues to address and where they want to allocate resources. So they want the ability to look at a high level, understand where do I need to deploy my resources. If it's something that they want to know a little bit more about, they do potentially want the ability to click in and see kind of the original data. But on the most part, they're looking for that higher level summary. Now, on the other hand, the technicians, they actually need to go out and fix the issues. So site-specific details, this many rows up, this many strings over, having the exact picture, these types of things can save them a ton of time. So it's important to understand your deliverable is kind of, it's going to be used by both parties. So I do want to dive into, on the next slide, localization for a sec, because it's really tempting to say, this is another question we get pretty often, that's, well, my images have GPS in the metadata, so why is localization itself, why is that important? Why is that something I have to think about? So let's say you have an image like the one on the left, and there's an issue with one of the modules. This image, it pretty much looks the same as the bunch of the images before it and a bunch after it, and it's pretty difficult to keep track of. And remember, you've got some error in your GPS measurement, your camera may be tilted, there is an error in a technician's GPS, so all of this kind of starts to add up. Whereas if you are literally able to tell them, oh, this is this row and the second module from the right, there's zero ambiguity there. And to give you a sense of why we do this, you can take a look at on the right of a utility scale site where you have lots and lots of different sites. Within that, lots of different arrays, each connected to an inverter, within the inverters, so on and so forth. It's a hierarchy. And so really understanding and drilling all the way down there is incredibly important if you want your data to be actionable. So what makes deliverables really high value is if they're useful, right? So you want to provide the managers with a summary grouped logically so they can manage and make good decisions, and at the same time give them the means to access all the details they need. So a good deliverable should integrate into the existing workflow, and this is something that being in the drone industry, we've seen some of the most successful companies are either on the integration side or the most successful drone service providers really dig in and understand clients' workflow and understand where they can slot this in to allow them to make better use of their time and lower their costs. So remember, this is not a standalone system, right? You want to be able to track changes over time. That makes it incredibly useful. Typically, the way that solar contracts are set up, you're looking at yearly or multi-year contracts, but there's always going to be an inspection component every year, and you want to be able to track how that asset is doing. And then finally, don't assume that your client is the only one who's interested. So oftentimes what we've seen is they'll get the deliverables, and let's say it's the operations and maintenance company, they're really excited to share that with the asset owners and show them, here's what's going on, here's what we're addressing. Oftentimes that can be used to help in that, both strengthen that relationship as well as help in that decision-making process to decide, whether or not the asset owner wants to allocate additional resources to fix something a little bit more major or not. So just remember that, your end, when you give your deliverable to your client, that may not be kind of the last place it ends, and they probably have a lot of things that they want to do with it as well. So to kind of wrap up here, I want to drive home that drones for commercial use is more accessible than ever before. Safety is obviously the most paramount thing in this industry, but there are now at least clear guidelines for how to proceed, and there's an entire ecosystem to support your operations. I think I mentioned at the beginning, knowbeforeyouFly.org, really good place to start off with. It's literally a flow chart. I want to fly drones for my business. Here's what you do. And this is why we're seeing a lot of drone service providers that are focusing on the solar space emerging, as well as a lot of operations and maintenance companies that are using a mix of potentially internal operations as well as outsourcing. Thermal imaging is absolutely critical. Most of these defects, almost everything we talked about today, can only be detected by thermal imaging. The visual, the color imagery is more to help distinguish between a couple different causes. Understanding the mission purpose, just driving that home is going to make your life easier and really help you optimize your data collection. The worst thing you can do is, especially as a drone service provider, is be out there all day when the thing your client cared about, you could have wrapped up in half an hour. So make sure you are matching that expectation. Optimize your data collection. So we talked about this, how to basically make sure that your data is really high quality and not take too much data and not spend too much time in the field. Spend exactly the right amount of time and most importantly, make sure your data is good. And then finally, deliver results that are going to be useful across the solar value chain, both at a high level for the people who are managing these assets, as well as the technicians who actually have to go out and act based on what you found out there. So with that, I want to turn it back over to Randall.
Amazing. Well, we're about to get into the Q&A portion of the presentation, and I truly think that that's probably the most value that you can drive from these sorts of webinars. So I appreciate everyone sticking through, and please submit your questions now so we can answer those. But I just wanted to make this announcement that starting today, we're launching our Delta video series. Some of you may have seen the Thermal 101 video that was posted yesterday, but the Delta video series from FLIR is a collection of free videos that are created by thermal imaging professionals in conjunction with industry experts. And right now you can go to the link that's shown here, and you'll see several videos that are just representing the beginning of what we're going to be doing as far as hosting content based off of aerial thermal imaging. And your viewership encourages us to make more content. And so check it out and submit your feedback. Based off of your feedback will be how we create videos in the future and start this dialogue of what aerial thermal imaging is really doing. So now it's time for your questions. So we're going to pull up the question box and keep submitting them as we go through this. We have another probably 25 minutes or so that we can spend doing them. So yeah, let's hit the questions. Let me pull up that box and we'll get started. All right, so this one is for you, Nikhil. Raptor Maps, as far as your software, can it be used offline, or do you need to have some sort of 4G or some sort of LTE connection while you're using the software?
Yeah, so we operate, we'll provide, as you guys can see, all of the guidance to go out and operate, but all of the data is uploaded to us online. So that's how our customers transfer the data, and that's also how the results are made available to them. So you definitely don't need to have any sort of connectivity when you're out in the field.
Perfect. So we got a question. It says, what do you expect to see regulations that will allow beyond visual line of sight flying at the solar farm site? So actually, and this is a pretty much a U.S. specific question that I'm answer, but beyond visual line of sight regulations vary from country to country. In the U.S., I would say that they're pretty much run of the mill, where it's restricted unless you get a waiver. I'm actually sitting on a panel with the FAA tomorrow talking about beyond visual line of sight flights. Now, FLIR, and you may know this, but FLIR is one of the rare companies that have been granted beyond visual line of sight waivers. So if you are interested in getting one of those waivers and want to discuss best practices or anything like that, I'd be open to sharing that with you. So feel free, sorry that I skipped this, but feel free to shoot me an email or reach out to Nikhil as well through our contacts that are listed here. But beyond visual line of sight right now, I would say without the waiver is few and far between. But in the future, we might be seeing that opened up as commercial applications of drones are becoming more and more prevalent. Nikhil, there's a question here about how high would you fly to get good data, just as a general practice. And there was also a question about how fast are you flying to avoid thermal motion blur.
Yeah, that's a good question. So, it really depends on your camera lens and your detector size. So typically for cell defects, you're looking at around 5 centimeters per pixel. So you want to try to optimize on that. It really depends on the combination there. So the best thing I can say to people is, on one hand, they're welcome to let us know what their setup is, and we can help you out. But on the other hand, we highly recommend doing a little test flight in a small section right beforehand and testing it out for themselves and really getting a sense of, okay, this is the optimal thing for this particular farm. So,
and for solar inspections, do you find that there's good and bad times to do the inspection?
Yeah, I mean, good times are definitely going to be when it's sunnier out, provided that the operator is able to minimize glare. Bad times are definitely, cloudy day, low insolation. That's not going to be as good. And then I guess I should point out, I know people are looking for kind of rough guidelines. So, what we found for a typical setup, going back to the altitude question, 13 millimeter lens for a 640 by 512 resolution camera, approximately 130 feet. So don't go out and fly exactly that and come back and say, oh, you told me the wrong thing. That's a, a pretty good guideline, I would say.
So we had a question come in about kind of the standards that you inspect to, and here we have one of whether you need to be a level 1 or level 2 thermal a certified pilot, and I don't believe that certification for thermography is necessary to do these inspections because it depends on what they're doing with the deliverable. But what have you found as far as feedback from sites saying, we want to certify to this standard, or do they just want to see the imagery?
Yeah, so what we found is typically they want to see the imagery and the relative differences. So what you don't need to be a thermographer to use Raptor maps at all. But that being said, if the data is if the data coming in is not reviewable, or we're not going to be able to see those differences, we're going to let you know and not process that data.
Sure.
And I guess I should also point out that everything we've shown today, that's all based on, it's all qualitative. So what we're not doing is saying, the temperature of this module is exactly this. And what we found is, if you want to get into warranty claims and things like that, for example, is it's really helpful to flag the suspected modules, and then the teams on the ground can confirm that with handheld thermography using the exact same protocols that they're already used to using. So again, it comes back to that workflow integration.
Sure. So there's a question that I'll take here about what is radiometric data. When we talk about radiometry, it's the difference of looking at an image and seeing a defect, or seeing the temperature differences as a range within the scene. What it's doing is giving you the exact temperature data of every pixel within the image. So when you're looking at a radiometric image, it's data that's provided so that you can do change over time. You can see that the temperature has changed in these panels, or you can see that one panel is 150 degrees Fahrenheit and the others are all uniformly 120 degrees Fahrenheit. That radiometric data is going to be shown as a number rather than just a visible image. So it's not just meaning thermal data, it's meaning the actual temperature rather than just relative differences within the scene. Nikhil, do you by chance have an example of a report or a deliverable available somewhere on your site that people can access, or how would someone know what one should look like?
Yeah, so we have a report available on our site on the blog, but we have we have much better ones if you contact us. So yeah, we'll definitely work on getting an updated one that's reflecting exactly what we're doing up on the website for you guys. Perfect.
And yeah, just make sure
yeah, Randall, going off of that, I did see another question that was asking, do you guys just do the PDF, or how does it work? And the answer again comes back to that workflow integration. So we provide the data in a lot of different ways: KML files, Excel files that link back to the original images, PDF reports, online portal. And the reason we do all of that and make all of that available is because our clients like to pick and choose the parts of that work for them. So you don't want to say, yeah, this is the only deliverable, because the idea is they should be incorporating this great technology into however is going to save them the most time.
So here's another question that kind of follows up on that, but I think that a lot of the people attending are wanting to do this sort of inspection for solar panels, and they're wondering, what is the cost, or what can you charge for a solar panel inspection? I would guess that it varies, but can you give a range of what someone might expect to do one of these inspections?
Yeah, absolutely. So I would say you definitely want to, in the industry, the standard is to charge on a per megawatt basis. And so you want to understand when you're working, let's say you want to fly for an operations and maintenance company, you want to kind of understand what's their yearly budget, and how is that going to be allocated, because what you do is going to be a part of a subset of that. If you're flying for asset owners and they might potentially want a really detailed report, you might be able to charge a lot more per megawatt. So it really depends.
Okay. So here's a question that came in, and it's about the technology, actual hardware that FLIR produces. So they're asking the difference or the benefits between using a Duo Pro and a ZenMuse XT. So let's use that as rather, what is the benefit of having a visible image and a thermal image just versus just having the thermal image while inspecting thermal imaging sites, or sorry, inspecting solar farms?
Can you repeat that?
Yeah, so what is the benefit of having both visible and thermal when you're doing an inspection versus just having a thermal image?
Oh, absolutely. Yeah. So in a thermal image, you may see that there's, something that looks anomalous, or might be a hot spot or something like that. But I think the most clear example we've seen is, you may have multiple cells that are heating up within a module, or you may have the surface of that module that just exhibits a lot of cracking. And that's something that you can see very easily if you've got both the thermal image as well as the visual image.
Perfect. So there was a question about warranties. What kind of deliverables have you found while doing inspections that were actually justified for warranties of the panel?
Typically, you're looking at several hotspots that are exceeding certain ranges temperature-wise, but we'll just flag the modules and then let the clients follow up with that. So they're the ones who are filing warranties and dealing with the actual module manufacturers. And I think that's really important because again, it comes back to providing a really good qualitative analysis, but without overstepping what we can do and what the current technology is, because we have a lot of people using this technology in a lot of different ways, and so we want to make sure we maintain a good standard and a good consistency in the deliverable.
I'm sorry to bombard you with these questions because you're the expert here, but
That's all right. That's what we're here for.
there's a number of questions here that are talking about the angle that you would be flying. So you said you don't want to look at the panel dead on, that you want to be at a certain angle. Do you have best practices there? And also for overlap if you're doing an orthomosaic?
Yeah. So in terms of we found 20 degrees off, up to 20 degrees is pretty good. Yeah. In terms of if you want to make an orthomosaic, we still stand by the 80% overlap and side lap, but I would say, if you want to be able to guarantee a deliverable, the orthomosaic is not necessarily the best way to do that. All of our analysis is on an image by image basis. So, you definitely can fly in a pattern that's going to give you an orthomosaic, but if it's a very, very large installation, we would not recommend it.
Okay. And do you want to talk a little bit about the RaptorMap software, what that software actually delivers, what it can do, and someone asked about the cost about it as well, so this gives you a chance for some self-promotion.
Yeah, absolutely. So what the software does is it will take in both the thermal images as well as the RGB images, classify everything that's going on, localize it, and then generate the deliverables in a lot of different ways, like we talked about. So make it available to your clients in several different formats, and then be able to track changes over time. So every module is associated with a digital address, and so the next time you might fly, if anything changed with that module, you would be able to compare that. So, and just like in the industry, we charge on a per megawatt basis for Raptor Solar. And I guess it is a good distinction is, we have the Raptor app, that's much more for drone data management. And then Raptor Solar is very industry specific product for solar. So those are two separate things. So don't be confused.
So there's a question a number of times that people are asking about integrating FLIR hardware onto airframes, but I want to start with the airframe or the platform that you use personally. Are you guys using like DJI equipment? Are you using other manufacturers? Do you have a preference? Is there a reason behind that preference?
Yeah, so our customers will fly lots of different aircraft, but obviously the most common platform is going to be the DJI. We've seen a lot of success with the Inspire One ZenMuse combo. That one's still pretty popular. We've seen people flying SenseFlies, but yeah, those are kind of the two of the bigger ones.
Sure.
Yep, and we're really excited about the Duo because then, that gives us the ability to, you have your guaranteed, radiometric data, RGB data, and then all of the metadata. So.
For sure. And one thing that a question that came up that I'll answer is about radiometric video. So right now, the Duo Pro R is the only thermal imaging camera that FLIR manufactures that has radiometric video. So if you're not doing an orthomosaic, but you just want to fly the entire field and then take images from that video and use them for radiometric data, that is possible only with the Duo Pro R. So that could be another way to shortcut some of these things so that you don't have a whole collection of images, but then you can take the images that you do want from the video and then process those. Let's see. Do you have a concept of what are the most typical, when you go onto a site, you said that you want to know what your client wants and what they want to deliver. What is the most typical thing that they're looking for?
Oh, that's a great question. We typically find that there's a breakpoint between clients who want to see, module level defects and larger. So this will be for utility scale. Or you'll have clients that want to see things like, activated bypass diodes and hotspots and things like that. So that's kind of the first question that you should ask. But definitely have that conversation in advance and understand what are they going to do with the results of your analysis.
So you talked about how you were charging for doing these kinds of inspections, but how would you plan out the amount of time it's going to take to do an inspection?
Yeah, that's a great question. So, that kind of leads off the last one where, if you know that a client needs a really high level of detail, then you want to plan for, what altitude do you need to fly based on your lens and your setup? How fast can you actually fly that based on your, based on kind of your setup and making sure that you don't have any blur. So you would definitely want to sit down and actually figure out those flight times. And the people who have done it a few times get a really good sense for it, and they don't need to kind of do out the math on the back of a napkin. But if it is your first time, it may be pretty helpful to go and play around with, your flight planning software and understand, okay, if I have this exact setup and I increase my side lap by this much or change it by this much, how does that affect my flight times, and go from there.
So because we started late, we're approaching the stop time, but I would suggest that we go about 10 minutes more. Are you cool with that, Nikhil?
Absolutely.
It looks like we definitely have the questions and people are still sticking around. So hopefully we'll dig into more and give more understanding about how this all works. We had a question come in about resolution for thermal imaging cameras, and I'm aware, FLIR generally produces 3 resolutions of thermal imaging cameras for drones: the 640 by 512, the 336 by 256, and then a 160 by 120. So that would be, the FLIR View Pro comes in 2 options, also the ZenMuse XT, and then the Duo and Duo R are the lower resolution 160 by 120s. I'm guessing you haven't tried using the 160 by 120, but if you have, fill that in. But have you found a significant difference in doing solar inspections between 640 and the 336 resolution cameras?
Yeah, the 640 definitely saves the operators a ton of time. So if you think about the footprint, it's going to be 4 times the area. If this is something that you're pretty serious about, we highly, from the data end of it, we highly recommend the 640.
Perfect. So we covered this sort of, but I just think that if you could give an idea of what is the best time of day to fly. Are you talking midday, or just, you said when the sun's the hottest? Is that going to be true around the world?
But midday, the biggest trade-off is just the glare issue. So without getting too into it, some of the installations may be on trackers, some of them may be fixed, and so you just want to make sure that you're picking a time of day that you're going to be able to minimize glare. So, definitely play with that gimbal angle a little bit, but yeah, you want midday for sure. Okay. So we've seen people try to fly like right at sunrise to maximize the length of their flight day, and that doesn't work out so well.
Jumping back to the ZenMuse XT, there's the difference between the ZenMuse XT and the ZenMuse XT-R to get that radiometric data. Would you say for someone that wants to do solar inspections that it is necessary to get a radiometric camera, or do you find that you're generally using just the performance relative temperature difference?
Yeah, it is highly recommended. So the challenge is exactly the one you saw, that if anything enters the field of view, in a non-radiometric camera that may kind of throw off that that color map, then that data is basically wasted. So we highly recommend. We've seen people with non-radiometric cameras be able to, in the most ideal conditions, be able to give us data where we can generate a deliverable, but we definitely recommend radiometric, hands down.
Perfect. I'm scanning through these questions, and hopefully you guys can bear with me because I want to make sure that we covered most of it. A lot of what you're asking is similar about direction of flight, the way to get the best data. And I think that as we send out the recording of this this webinar, that you can review how Nikhil explained the best way to capture this data, and maybe be able to pull out the information a little more clearly as you hear it a few times. But Nikhil, do you want to touch just again on how you would best fly a farm? If we all imagine the farm, the panels are facing us, would you fly along the grain, or would you fly perpendicular to that?
I think either or we've seen is fine. The worst is to kind of fly at an angle that's neither.
So like a mix. Right.
Yeah, absolutely. So what you want to do if you're in a multi-copter is, you want to match match kind of that gimbal angle roughly to the panels, but minimize the glare, and then you can choose which direction you want to fly along.
Okay. What about like areas where the temperature is extremely hot? Because obviously that's where they're going to generate the most solar energy. So I know out in between Las Vegas and the California border, there's a huge farm there, and the temperatures can get 120 degrees Fahrenheit in the summer. Would you still be able to do an inspection then, or is it pretty seasonal?
No, we've seen we've been able to see differences on really hot days. Yeah.
Okay, so there's no problem. Would you be able to do a solar inspection during the winter? And also, would you be able to do one if there's any sort of like rain on top of the panels, or if it recently snowed?
Yeah, so that's a no for the rain or snow.
Yeah.
And yeah, in the winter, especially at the higher latitudes, if you can kind of look at the curve for the amount of sunlight you're getting. So if you're midday in the winter versus midday in the summer, your insolation, just meaning the amount of sunlight, amount of energy that's coming from the sun, is going to be a lot more in the summer as opposed to the winter. So the results are not going to be as good in the winter, and you may not see the differences you're looking for in the dead of winter, even if you do happen to get a sunny day.
So there's a couple questions about the Know Before You Fly site, and I can say I've never used it. So is it just knowbeforeyouFly.com?
I believe it's .org.
.org. Yeah. Okay, perfect. That should be suitable, but knowbeforeyouFly.org. And maybe you could explain a little bit of why that's been beneficial for you to use.
Yeah, and it's been really good because we love helping people through how to capture the best data to get the job done. And there's there's also kind of the getting started component, just basic drone stuff like what is a Part 107 license, and how can I get it, and understanding airspace authorizations and things like that. And I think it's getting a lot better. You're even seeing some beta programs where you can automatically, request authorization to fly very close to a major airport through some of these new FAA systems. And so websites like that just kind of spell it out really nicely for you, where these are the steps you need to take in order to get started flying drones commercially.
Perfect. I'm seeing just a lot of questions that are repeats of what we've already answered. We'll just leave it open for a few seconds, but I do want to say thank you again, Nikhil, for sharing all of your very valuable insight about doing solar inspections with drones. I think that we're really taking the drone industry as a whole, to the next level in using drones for purposes like this. And solar is one area where there's a clear opportunity to make the best cases for drones that are solving problems and creating efficiencies. So I would say that as we work through these last questions, make sure you reach out to myself. My email's up there, randall.warness@flir.com, or go to raptormaps.com/solar. Feel free to reach out to the Raptor Maps guys as well. Obviously, Nikhil knows his stuff. He has a team that he's working with that are eager to help you get off your feet and start flying. And again, the recording of this session is going to be sent out in the next few days. So make sure to check out for that. And also for the FLIR Delta videos that I mentioned earlier, go and check those out. I think that the information there is extremely valuable. It'll kind of set the tone for communication about aerial thermal imaging throughout the industry. And as you see areas where we can increase your understanding about aerial thermal imaging, we'll try to make videos that cover that. So I'm going to look just for the last time at these questions. We have maybe 4 more minutes. And again, I appreciate everyone for sticking around.
I can look at some of these quick ones here, and then obviously some of the ones that may take more time. We're definitely going to be looking at all of these afterwards and posting some detailed responses to ones we didn't get to. But someone asked, why not the Inspire 2? Certainly nothing wrong with that. We were just kind of describing what we've seen, in the past. But obviously there are a lot of these newer platforms coming out.
There's a question about insurance policies. If there's a special insurance policy for doing solar inspection, I would assume that it's just the general million liability insurance, but do you have any insight on that?
Yeah, if you have a service agreement with a company, they'll specify what insurance they want to see. Yeah, otherwise, if you just kind of make it clear to them, here's the insurance that you have. Typically, especially if it's a pilot or a proof of concept, it tends to not be a big deal.
Okay. So a question here that I think is actually really interesting because I've never done it is how are you approaching solar companies? I mean, what is the best way to get their ear and have that conversation about why they should be using drones?
Yeah, I mean, what we've seen is that companies they're learning quite a bit about the space, and they're recognizing how valuable and useful this technology can be. And so, they're starting to reach out both to, providers in their area, to companies like ours. Like if you're on the drone side, understand that these companies are just as hungry for knowledge and to make this happen as you are. So.
Perfect. Well, I guess we'll just wrap up. There are a lot of questions that maybe we missed some. If you see this panel, you'll understand why it's hard to parse out what we've answered and what we haven't. But all the questions that have been submitted will show up to us after the webinar is over. We'll go through there and try to pick out the ones that we didn't answer and shoot you emails personally. There was some about products and pricing and things like that I'll get to offline. I'm sure Nikhil will find some in there that he can respond to. But again, we really appreciate you guys taking the time out of your day to join us. Apologize for any technical difficulties up front, but it's been a really great webinar. Nikhil, you're the man. Keep doing what you guys are doing at Raptor Maps, and we look forward to hearing from everyone and keep doing what you're doing.
Yeah, no, we really appreciate everyone being on the call today. This was fantastic. I hope we were able to teach you something and keep these great questions coming. So, perfect. And yeah, we will answer more questions in a blog post that we'll post online later this week. So if we didn't get to yours, don't feel bad.
Yeah. Appreciate it, everyone. Take care. We'll talk soon.